Good morning, good afternoon, everyone, depending where you're located. Thank you for joining us. We're happy that you joined us on this hot topic, data centers and noise control. Before we get started, I wanted to mention a few housekeeping items. We probably will not have time for a Q&A during or at the end of this session, but since it's such a large group, there is a section questions feature in your control panel. Please leave any questions you have as developed throughout this presentation, and we will get back to you directly via an email, which will be nice because we can elaborate our responses. Also, there's a handout section on your control panel. Take a look at that. There's a few items in there that you might want to look at that are referenced in the presentation here. So with that, I'd like to get started. Once again, welcome. We have all different disciplines in the audience here. We have data center designers and managers and facility engineers and architects, engineers, acoustical consultants. We have equipment manufacturers, and I'm looking at independent reps and also some of our friends here at Kinetics. So great crowd. Thank you for joining us. As we start, you saw the invite had the title System of Mechanics to Run a Data Center. As we were putting this presentation together, in a nutshell, it's basically data centers. Why, where, and how do we address the noise? So that's kind of what we put in the title here. We're looking at a data center. Many of you know what a data center is, some of you don't, but in the simplest form, it's a giant building. It has a lot of power, which generates a lot of heat. It has a lot of cooling. It has a lot of computers and servers and a lot of security. And key thing, it's supposed to operate 24 hours a day, 7 days a week. And here's some pictures of some different data centers, different data center companies across the world and their campuses. So just to kind of get you in the mood, that's what we're going to talk about. Why are data centers proliferating and what drives data center demand? Well, we looked at that a little bit, and to summarize once again in a very easy fashion, it's driven by our current technological dependence, the new norm. Although data centers have been around for tens of and 20s of years, but it's our new norm. It's our crescendoing norm, if you want to say, for those of you that are music experts. But currently, technology-driven lives. And you know, the data center is designed to ensure secure, dependable, efficient environment for data processing and storage. I read in a lot of articles I thought was interesting, it kept resonating, was they would say people are addicted to data centers, and really they are. They're addicted to what they do for us. That is e-commerce, business data, streaming, social media, web hosting, cloud data, disaster recovery, cellular, mobile, etc. Now, we've kind of been going along. We have data centers. Data centers are developing at a kind of a constant rate. But lately, with the development of AI, artificial intelligence industry, we're looking at an exponential expansion of data centers all over the world. And I looked at a note. This is fresh out of the Data Centers 2024 Global Outlook report. It wasn't hard to find, because this is such a hot topic, it wasn't too hard to find current event information. But it was really interesting that with the development of AI, data center storage capacity expected to grow from 10.1 zettabytes in 2023 to almost more than 2 times at 21 zettabytes in 2027, for an average annual growth rate year over year of 18.5%. Now, in my mind, I can talk about terabytes, I can talk about gigabytes, I don't talk much about zettabytes. So I looked it up just for everybody's edification. Was 1 zettabyte equals 1 billion terabytes. And so we're talking about 10.1 billion terabytes versus 21 billion terabytes. And I guess that's where the name big data comes from. The strategy of considering when determining where to locate data centers. So when we look at the whole world, all these dots, whether they're blue or green, this is the location of data centers. And if we looked at Europe alone, you can see the location. You can see the UK, Netherlands, Belgium, Switzerland. And then in the US, you can see similarly high concentration areas such as Boston, Philly, New York City, Los Angeles, Orlando, up in Seattle. You can see a lot of areas on where the data centers are sprawled out. In some areas, you see none. Just another statistic, and this is all to get you in the mood to talk about data centers and noise control. But if you look at the worldwide comparison and you look at the data centers, the leading country by number of data centers as of March 2024, just a few months ago. If you look at the top 5 countries, you can see how many data centers there are in the US at 5,000, almost 5,400 data centers, compared to the next in line, which is Germany, 521 data centers. In fact, if you add the quantity of data centers in the top 12 countries, you still don't equal the amount of data center expansion that's happening in the United States. Just a comparison information there. When you look at where people say, why did I put this data center in my backyard? Why didn't they put this data center in my backyard? That goes both ways. When planners for data centers on where to place them are going through their design phase and focusing on where to put it, they look at connectivity. They look at the network congestion in different areas. They want that latency in milliseconds, that ping. How long does it take to send a ping out and receive it back? And is there any delays in that? Certain part of the country, as you know, or part of the world has more reliable access with high-speed internet than others. What we found out too was you may see a bunch of data centers in a territory, like maybe 3-4 campuses. But what we find out is organizations tend to not just have that territorial campus of data centers, they'll spread them all over the world or all over the country because it's more reliable that way in case one area has an issue versus another. They can immediately transfer over to another part of the grid, if you want to say. Power. They look at the potential downtime in some different areas of the world in the country due to outages affecting the area and the capacity to produce power. These data system centers want to run on municipal power. They have backup power, but they really want to run on constant municipal power. It's very interesting that if municipal power, just a side note, if municipal power goes down, the uninterrupted power supply needs to, like the generators, diesel driven and that, need to come up to speed in like 16 seconds. Now, some people may say quicker or a shorter time period or longer, but 16 seconds to come up to full power again. It's like taking a 53-foot trailer haul full and going from 0 to 60 in 16 seconds. So it's a huge amount of energy, huge amount of heat. Natural disasters, they look for that. Natural disasters in an area over the past 5 to 10 years. So this is how they look at where are we going to shoehorn in a data center, or can we move it out of the municipalities? How do noise issues arise and why do they need to be addressed? And why do we even care? I know that sounds funny, but why, noise is noise. Let's quiet it down a little bit and move on. But really, if you look at the CDC, Centers of Disease Control and Prevention, noise can cause stress. And many of you know this, okay? Noise can cause stress, anxiety, heart disease when somebody's continuously exposed to it. Noise issues are not just related to hearing loss, but instead much, much more. So remember this: stress, anxiety, heart disease, continuous exposure when we move throughout this presentation. There's 2 types of noise that we're going to be concerned with. One is inside the data center. And then the next slide will talk about outside, the environmental noise, outdoor noise. But inside, I think we all know that excessive noise levels make it difficult for staff to concentrate, communicate, perform tasks effectively. Do you have to raise your voice to be heard? There was a good rule of thumb that I read a long time ago, and I don't remember if OSHA published it or in one of the articles or manuals I read. But when you feel the need to shout to be heard 3 feet away, the noise levels are probably 85 dBA or more, and action is required. Of course, that depends how long you're exposed to that noise level, and also whether you need to incorporate a hearing conservation program. But that's my little figure here, kind of shows you if you have to shout 3 feet away, you probably have a problem. I looked also at some research, and it showed that over here we have listed A data center hall untreated, just a data center hall operating, usually the power supply fans, usually mid to high frequency, like 500 hertz and above, noise is driving it to about 80 dBA. A vacuum cleaner, for comparison, might be 75 dBA. An alarm clock might be 80 dBA. That was kind of subjective, because how loud do you put your alarm clock? But let's move on. Conversation, though, more importantly, normal conversation is about 60 dBA without having to shout. So when you look at the 80 dBA and the 60 dBA, you can see there's obviously a noise issue, a communication issue within the space. And something to remember with sound is dropping a noise level 10 dBA. Let's say you went from 80 up here to 70. You would perceive that as sounding half as loud. And all of that has to do because it's logarithmic, but it doesn't take a huge noise reduction to have a noticeable difference. Outdoor noise. Outdoor noise is interesting because the data centers, once they're all up and running, all noise sources, which we'll cover noise sources in a few minutes, but all the noise sources, everything operating efficiently, and the data centers just working great. We have to be concerned with property line noise issues. As I mentioned, where do you put a data center? Sometimes you're going to put a data center right within an area where there might be 1,000 home or a 500 home or a farm next door, people that have been living there for a long time residentially, and then you put a data center in. So property line noise ordinances are very important. It's also very important that it's fair, that noise ordinances are fair. Some noise ordinances around the country, depending where you're at or around the world, might simply state, you shall not negatively affect your neighbor. Well, that's pretty subjective. That's really not a good noise ordinance. Very hard to enforce and not fair to especially the person that's making the noise, but also the people, the residents that want it to be quiet. So a good property line noise ordinance usually takes into account the zone use, whether it's a low density residential area or whether it's high density residential or all commercial and manufacturing area. One interesting thing that's coming up now, though, is that where you used to have a buffer between residential and industrial with a commercial zoned area right in the middle, well, now you're seeing industrial and residential coming right side by side. So what they'll usually do is set these property line noise ordinances. They'll split them up between daytime and nighttime, and then hours, maybe 7 a.m. to 10 p.m. and so on. And that's a very common, probably one of the most common breakdowns if you look at about 50 different noise ordinances. When we look at outdoor noise, it's predominantly low frequency noise. High frequency noise, one thing about high frequency noise, like 1,000 hertz and above, it's great because your ear is very sensitive to it. So it doesn't take a lot of energy for you to notice it, which means since it doesn't take a lot of energy, that energy can propagate, and over propagation, it then reduces itself naturally. Whereas low frequency, it takes a lot more energy for you to sense the loudness or the intensity of low frequency noise. And because of that, it is full of a lot of energy. And that energy can propagate very long distances, like 500 feet, 700 feet, a quarter mile, a half mile, or even a mile. And sometimes to a point where the ears can't really hear it, but it's there. And that shows in the chart to the right here. If we look at low frequency on the left and high frequency on the right, at a data center, what you find is you have, after all the systems are running, you tend to have this low frequency noise issue. This is true for other industries as well, but in particular, since we're talking about data centers, this can happen. So it's not that they're unique, it's just something that can happen. And we're talking about frequencies a lot of times down here that you really can't hear, but you can measure. Okay, you can measure it with a sound level meter, but you can't really hear it. Now we look down here, a neighborhood near the data center, you still see some of them low frequency spikes. And then with no data center, you might see some ambient low frequency, but not much here. Remember that first slide where continuous exposure, anxiety, heart disease, other problems, even if you can't hear it, this can become an issue. So types of noise generated from data centers. I love the equipment side of the business. I think it's very important when it comes to noise control. You have to know how the equipment operates. Noise control is kind of second hand because the key is with any of these systems we're going to look at, these pieces of equipment, they need to operate. Warranties cannot be void. Air passage, cooling, everything needs to operate as it was designed to operate. So it's very important that anybody that tries to design noise control solutions knows about how the equipment operates. But we look at air-cooled chillers, you have a system issue here. And if this are actually air-cooled chillers at a data center. And it says system noise. You have the compressors down here that are making noise, and then you have the upblast fans up here making noise. When it's a community noise issue, an environmental outdoor noise issue, you have to address both. A lot of people say, well, let's just wrap the compressors, but now they still have all the noise from the upblast fans. So you have to address them both. And unattenuated at these units, maybe a meter away, you're looking at about 98 to 102 dBA. And depending how far the property line is away and natural attenuation and distance effect, you might need to quiet these down. The next thing is cooling towers, and cooling towers are Cooling towers are interesting because you have those the intake noise on the sides, and then you have those large 10-foot, 12-foot diameter fans on the top, and they all make noise. These run a little quieter unattenuated, about 86 to 98 dBA. But once again, if these are induced draft cooling towers, then they don't have a lot of external static. And once again, you have to know how the equipment operates before you start applying noise control. Noise control can be applied and it's an awesome thing, but you just have to make sure somebody understands how the equipment operates. I was running on a side item here. I thought standard residential AC units for your house. You might order a 3 to 5 ton unit. I thought it was interesting. If you look at one of these units, now there's a redundancy here, of course, but if you look at one of these units, one unit is about 1,050 tons each, whereas our houses are only 3 to 5. I like those comparisons. This is big power. This is big cooling, hence for big data. Air handling units, you have intake noise, discharge noise, casing radiated noise. Sometimes the cooling, instead of being air-cooled chillers and up on the roof, sometimes they're cooling units on the AC units on the side of the building. Once again, we need to address all these noise issues, both indoors and outdoors of the building, and that unattenuated runs about 85 to 102 dBA. Then indoors, we're looking at the diesel generators, rotor UPSs. We got the casing rated noise off the generator. We got cooling fan noise here outside the building. We have engine exhaust noise then. These all have to be taken care of. And unattenuated in a generator room, you're looking anywhere between 100 to 110 dBA. So this is just, once again, there's noise running a data center. So noise control products and their successful application is the next bullet point. I often go through different products, or I've seen people go through products, whether it's noise control or ventilation or whatever. And as you're looking, you're thinking of your applications and saying, gee, I wonder if I could use this here in my facility. So we thought, let's put a slide in here at the beginning that kind of talks a little bit about that. So here I would put the following noise control products are applicable to any of the following data center critical areas. It could be the main data center floor area with all your servers and all your cooling. And it could be the cooling plant. It could be a centripetal UPS room, a generator room, a pump room. All these rooms where noise is being created is where these products can be applied. One of the products we wanted to start with is a Model S4 panel. And S4 panels are insulation panels that have a scrim-faced outer layer on them. They're all independently tested. Also, preface, all the products we're going to cover are independently tested per the applicable ASTM acoustic test standards, acoustic and also pressure drop test standards. So everything is independently tested. You know under test conditions how it'll operate, so then you can properly apply it to the application. But if you look at the S4 panels here, they can be anywhere between 2-inch or 4-inch thick. They can be pinned, they can be stick pinned or frame mounted to the walls, stick pinned to the ceiling. Over here, you got a generator room. You see they have either white or silver facing. And in the generator room, you can line the walls and the ceiling. Here, they're actually run between the joists. And you can kind of see some little straps in here because you're saying, well, I couldn't pin those because we kind of have them setting down a little from the ceiling or the underside of the roof structure. But what you can do is you can kind of see them here a little closer. You still can't see them that great, so we annotated in what those straps. Typically, those straps are about 2 to 4 inches wide, and they're made out of aluminum. They're very light, and they can be used to suspend this and basically just lay those. So everywhere you see these straps, everything where you see these marks, those straps are. When you look at these products, you say, okay, there's an initial cost. We think it's important to explain that installation is extremely easy, low cost. So you're either going to stick pin them in place or use the aluminum straps. This product comes all factory cut to size, so you can fit it in the spaces. You may look and say, do I have to cover 100% of the walls and ceiling? The answer is no. We can run a reverb analysis for you and determine how much coverage you really need based upon the amount of noise control. But absorption alone does only offer about 10 dBA reduction. But remember, 10 dBA reduction, maybe it's not quiet enough on a sound level meter, but it will be perceived as sounding half as loud. Another product is model PET absorbers. I like to put the name up there, polyethylene terephthalate, because it's a hard word to say and it's kind of fun. So I popped that in there. And this is a recycled. Picture all your plastic water bottles crunched up and ground up and recycled. So these can come in 1 or 2 inch thicknesses. They can even be double layer up to 4 inch thicknesses. And those can also be pinned up to the walls for absorption. Also, all the products we're presenting are at minimum Class A fire rated. Some of them are even more stringent. So these are all the important things you need for indoors. But if you look at the PET panels, they have impaling pins. There's guidelines on how many pins you need. Those are usually mechanically fastened to the wall substrate. And then paired with those is a mastic construction adhesive. So very easy. These can be field cut, unlike the S4s that have to be factory made to size. These can be field cut. Another option is to use a quilt. This quilt comes in either a 2 or a 4 inch nominal thickness, meaning it's that size before you stitch it. So it decreases a little bit. Once again, all independently tested. But in this particular application, we were adding absorption to the walls. And it doesn't, there was too much congestion below, and we only needed to drop about 8 dBA. So around the plant, these also come in various colors. They can match your company colors. They can even have silk screen patterns on them. But they're just hanging here. They're a very light product, no mass. It's very fluffy, very light, and they're just have factory grommets in them, and they're just hanging. They're basically 4 feet tall, 20 foot long, and then you go to the next one and the next one and the next one. And these walls can be hundreds of feet long. You can also use an outdoor version of that quilt. Let's say, you know, we're always looking at, we have a budget. You either are retrofitting noise control. Wow, we didn't plan that money in there, but we're getting noise complaints, or it could be new design. In a retrofit, if the budget is limiting, then you can use this outdoor quilt. Put furring strips behind it, and you can line the walls of it. This was normally a 14-foot tall cinder block equipment yard, and it had a lot of air-cooled chillers in it. It was making a lot of noise, and the neighbors in the right picture, you can see the neighbors are about 100 feet behind this 14-foot wall here, and they were even up a little bit. So there was some problems there. And then there was some noise on the compressors here. So they have our quiet shield compressors on them, barriers on them that are quilt and barrier all in one, but all meant for outdoors. Another option in generator rooms or pump rooms or anywhere is wave baffles. You see some wave baffles over here that actually fit in. They don't interfere with the sprinkler system if placed correctly. They don't interfere with the lighting. And then the same thing is the hanging baffles here. These are 4 foot tall, 8 foot long. And we can help you decide what coverage you need, what pattern you need, how many you need by running our reverberation analysis internally. And I also put in here, once again, these are easy to install. You can use cabling here and hang the baffles if they're going perpendicular to the beams, or you can run them along the beams, depending how your building's situated. And then the wave baffles are just using furring strips. You got your corrugated roof structure, furring strips, lag screws, and fender washers, and away you go. They also come in various colors. Outdoors, for maybe new construction, or the budget allows, whether it's a retrofit, these are rigid perforated panels. There's no solid back on them. The solid back is the equipment yard concrete or cinder block wall. And these can come in 2 or 4 inch thick. They can also be offset mount off the wall here with an airspace between them, increasing the absorption they can exhibit. But these are all factory powder coated products and can be installed, made to size. Once again, very easy install. If you look at the install, you have a top Z channel, a bottom J channel. There's also different ways you can use mounting clips, but it's very simple to install. You anchor to your substrate, you mount your panel in, put the top cat anchored. And if these are long walls, let's say 50 feet long, 40 feet, 100 feet long, then you could put 10-foot sticks of these mounting trim in and slide the panels in from one end. So straightforward installation. You have your initial cost, but labor to install is low as well. Then you say, John, I looked at all these different products. How do I know which one I want to use? Well, part of it is, which do you like? What appearance are you looking for? The other one is, though, is if you look here, we've graphed the sound absorption coefficient on the y-axis, and on the x-axis, the center frequency. The test standard C423 for sound absorption goes from 125 to 4,000 Gay. So that's why we're only publishing that. When somebody says, well, what's the absorption at 63 hertz or 8,000 hertz? There are extrapolation guidelines, but they do fall out of the realm of the test standard. But what we do is we look at the space, we run a reverberation analysis, and then we determine based on cost, maybe the budget, maybe the look, and how much absorption you need, which one would be the best. If you look here, it shows the S4 panel. The S4 panel gives you really good low frequency noise control. It gives you very good then high, mid to high, but it starts to drop off. If we look at the quilt, not as much low frequency, but it does good at 1,000 hertz and above. The K&Ps, same thing, good low frequency like the S4 and starts to drop off on absorption. But if you look at the PET, the recycled plastic, it does very well, really good in the low end, and then hang time is really good, or shall we say, the absorption is really good through the rest of the frequency bands. So there's just some things we look at. We look at air-cooled chillers. Remember, we talked about there's 2 types of noise. There's the upblast fans at the top, and there's the compressors at the bottom. And so we want to look at that. And these are chiller stacks. These are all perforated inner shells, perforated baffles, solid outer shell. Comes with optional doors if somebody wants doors to get in. But this shows you equipment yard here with some curtains, but it actually shows these are all designed, structurally designed and PE stamped in-house to meet the local IBC code, and no weight acts upon the unit. Same thing here, you can see a side view. It shows the baffles, the upblast fans, nothing touches the unit. The units were not meant to support any acoustic solution weight. Then we have our double wall panels, noise block panels. This is to absorb and block sound. So you're going to absorb sound, you're going to block sound, and we can use this for barrier walls, buildings, enclosures. They come structural engineers, straightforward to install. And what we see on data centers very often is they're replacing vision screens, non-acoustic vision screens, on the roof of the buildings to acoustic screens to meet the local noise ordinance. So where a vision screen non-acoustic might have been fine, maybe part of that system or all that system needs to be, the vision screen material needs to be replaced with an acoustic panel. And that's where those noise block panels come into play. And a lot of times a third party will already design the structural steel. And by designing that structural steel, then Kinetics will design the attachment methods to the third-party structural steel. And this shows a couple different types of that. We also, all our structural engineers on staff, work with the structural engineer of record that designed the support system and make sure everything melds up. And we can also provide the PE stamp. This is a great example here. It shows that surface or flush mounting. This one here is the best. It shows the flush mount where you don't see the tube steel behind, but here you can see I'm not lying, there's actually tube steel behind. So that's what these pictures show. Very nice. Sometimes you see knee braces, we cut around them. Sometimes they don't need knee braces, they're freestanding. These walls can be very, very long. Another option is where you're doing, Kinetics is doing the structural steel altogether. And we're designing everything from base plate upward. We're supplying the steel, manufacturing, design, and all the acoustic panels, access doors, and everything, all designed per local IBC. This is a data center project. These are 2 data center projects. And the architect in both cases wanted the look. They wanted to be able to see all the structural steel has external flashing over it that's powder coated, but they wanted to have this look. So you see the roughly the 3.5 foot tall parapet. You see the 12-foot wall that starts below the parapet and works up to the top. These walls are about 600 feet long, and at least in one direction. The other direction was about 100 feet long. So they're very big. We can also, when the data center is very close to a residential high rise or multifamily high rise with balconies, we can also do the coifred wall tops as well. Acoustic louvers, I love them. They're stubby ventilation silencers, typically anywhere between 4-inch deep to 24-inch deep, whether it's a generator room and you're filling the holes, whether it's an equipment yard, no top for cooling towers, or sometimes it's equipment on the roof and the architect really likes the look of these horizontal lines. So instead of using a solid barrier wall panel, they use that. There's many different models at Kinetics for louvers. I really do believe we have the most louver models available. And because of that, we can tune louvers, not just from our standard models, but from non-standard models using our SolidWorks and finite element acoustics to tune it to your noise issue. You can see a large bank. Louvers are made. This is roughly 200 inches tall and 180 inches wide, 24-inch deep. A lot of smaller louvers banked up in these spaces. You see a lot at the data centers. You go down the highway and you see many of these openings. In many cases, they have to replace weather louvers and put in acoustic louvers. Mounting louvers to third-party steel instead of the barrier wall system. You can mount louvers to that. And there's different, this is an example here. You see the steel behind it. You see this top system, and I actually put in there so you can see that better. And then the bottom attachment here is a continuous channel, and that's all engineered to be the proper gauge, the proper structure strength to meet the local IBC wind, pullouts, and uplift. And then here, always happy contractors installing, but really seriously, it's nice to show how the louvers can be mounted in with backing steel. And sometimes the backing steel is needed and sometimes it's not. Ventilation silencers, often we'll see this picture, a bunch of weather louvers. They're having noise issues at neighbors 1,500 feet away. They come in later and you see the sound level readings, usually 4 a.m. in the morning with the lowest ambient outdoors. They fire up the backup generators, take the sound readings. The next thing you do is you treat the inside of that with acoustic louvers. These happen to be 5 feet deep, but you have a large acoustic louver bank. You apply your then motorized dampers to that, and now you got the fresh air intake to your generator room. And then the outside looks typically like this. So, you know, there's over 1,000 models. These are all independently tested. Kinetics has over 1,000 models of rectangular silencers, round, elbows, and straights. And then if it's a large bank of silencers, we can do that as well, but not just sell you a bill of goods that might be small building blocks of silencers, but also help you, depending on the width and height of this, sometimes these can be 20 foot tall and 40 feet wide, is help you determine the added structural steel you may need as backer structural, because even though these have holes in them, what I've always been told by our structural team is you still have to basically, per IBC, in most parts of the country, you can't give any credit to those holes. You have to treat it like a solid barrier. So it has to have the backing strength. Upblast fans, there might be 50 of these on the building. You have them turn on, gravity damper opens up, and we can design baffles internal to these circular silencers. So when the gravity damper opens and it's fully open, then we can mate the width or thickness of the baffle to be no greater than that to keep these low pressure drop silencers for those exhaust fans. What's really interesting, and we're almost towards the end here, we have about 2 more slides, and I appreciate you spending this time with us, is vibration isolation. Kinetics is well known. In fact, this was our start in life in the early 50s, was vibration isolation. We do a lot of vibration isolation and seismic restraint. One thing for data centers, if you look at the picture in the lower right, and I hope you can see that, you have your raised floor, you got your servers, everything's cool. You got your, what a lot of people call them crack units, computer room air conditioners, okay? And those air conditioners have coils in them. They take hot air from the room into the top. They push cool air below the floor and up through the floor registers. Now, this raised floor is usually, I've read it in a lot of things, it seems like 42 inches is a very common height of that floor, that raised floor. Regardless of what that height is, those crack units, those air conditioners can sit on top of this structural frame that is both seismically and vibration isolated. And so they can mate that, and now your units are all isolated. And I put a little note down here, you'll see on this in the next slide, because I saw it in a number of things. I even saw it in some interviews of some data center facility managers, is vibration is the enemy of data centers. And it's very important. So whether it's the UPS systems, whether it's the servers and all that, and then of course seismic is an issue. So we have here, these can adjust with flexibility of height, vibration from 1/4 inch to 4-inch deflection for added efficiency, and different cutoff frequencies, and everything's mounted, drilled, ready to go for you. So those are great. They're very applicable. We see them in a lot of data centers. They also come with optional silencer scoops. Silencer are just turning vane scoops, so those are built in. And then also optional grills. These are actually 3 of those stands stacked up with grills around them. And so those have been some requests. So really, whatever you need, that's what we got. The next thing is isolation products. This is actually a pump room from a data center. And you can see all the inertia bases with the isolation springs on them and the massive inertia bases to control the vibration here. Floor mounting spring systems, spring isolators, seismic restraint cable kits for piping and ductwork. And then once again, vibration is the enemy of data centers. And in some data centers, it's important in all data centers, but some data centers, it's even more important, such as whether it's a cellular data center or something that supports a hospital, different things like that, very important. So with that, I'd like to conclude. Once again, I'd like to say, put your questions in the question features on your control panel. Look at our downloads on the control panel. My name's John Sofra. I've been in this business, both ventilation and acoustics, for about 35 years. This has been my life. I love it. I love noise. When somebody calls and says we have a noise problem, I tell them I love them, because noise is great and we want to help you solve it. We do have different sectors: in-plant noise control, industrial, environmental, outdoors, and commercial attenuation, duct system ventilation silencing, and specific email accounts for those. With your questions, we will definitely sit down the team. We'll give you personalized answers and respond. So I really appreciate your time. Have a great rest of your day.